All right, so now we should be recording. Okay, so again, an equation is like a scale because it's supposed to be in balance. Like both sides are supposed to be equal. The value of the left side of an equation is supposed to be equal to the value of the right side of the equation. Ah. Now, let's try that again. Not frozen. So if we, that's actually not. So if we look at a picture of a scale, again, right now there's nothing on the scale at all. Nothing on it, so it's in balance. The left side is the same height as the right side. That's the equivalent for an equation of the left side being equal to the right side. So this time I'm going to take a shortcut. Well, until I can board working. Do my best. So we'll say 10 on the left, 5 plus 5 on the right. The value of the left is what? 10, right? There's 10 there. That's all I got. An equation is just all numbers. Even if we see a variable is a number, and we just don't know what the actual number is yet. So the value of the left is 10. The value of the right is 10. 5 plus 5. If I do something to one side, so if I come over here, I have to subtract 1. Do. Now what's the value of the left side? Kanosh. Kanosh. So the process in this class is, if you don't, I'm not going to babysit. I'm not going to sit here and try to get you to work. I am obligated to let parents know you're not doing anything in class. So, and if they don't care, then there's nothing I can do outside of that. And I get some days you're tired, but again, you're expected to work in class. So I got to let your parents know that you're not. We'll just start at the front then. So Angela, what's the value of the left side? Still 10, right? I didn't change anything on the left side yet. What's the value of the right side now that I said to subtract 1, which is hard to read. What's the math? Do the math. All right. What's 5 plus 5? What's 10 subtract 1? 9, right? So is it in balance now? Left side's 10, right side's 9. It's not, it is not, it doesn't depend on anything. It is not in balance. What did I just say an equation is? Left side has to equal the right side. It doesn't right now. Left side's 10, right side's 9. I have got to do the same thing. So if I'm going to do this, subtract 1. I'm going to subtract 1 on the right. I have got to subtract 1 on the left. So now this is 9, but because I did the same thing on both sides, it is still balanced. 9 on both sides. So I don't think I've had you guys write this down. I had my geometry class because they did some stuff that required algebra already. Write this down. So an equation you should already have written down. If you don't, you can write that. The value, and I would write it up there, but I guess I could. You can type it. So here's what you need to have. This is Mr. Gill's definition of what an equation is. I'm going to write that, and good point, because you always need to have it in your own words. If my words don't make sense, then you need to ask me to explain it and then put in your own words. And value just means what's the final number. Like after you do all of the math. Okay. Value of the left side, and again, value just means do the math. Add up all the numbers. Now, if there are variables in it, you can't add them up and find out what the value is, but it still is equal on both sides. We just don't know what that value is yet because there's a variable. We may have some missing information like we did. I think I said, if you're going to the movies, how much are the tickets going to be? Well, if you don't know how much one ticket is, you can't say how much the tickets are. So then you would have some missing information. You'd have a variable. But regardless, when you create an equation, the left side has to equal the right side, even if you're missing something. Now here's the next thing that you need to write down. So that's the definition of equation. We are now moving into solving equations. And if you do this, what I call Mr. Gill's #1 rule to solving equations. So now write that down. Mr. Gill's #1 rule to solving equations. Zoom out a little bit. I guess I'm going to probably have to do almost everything by computer until I start it over in between classes. Let's see. So again, that was Mr. Gill's definition of an equation. Now this is, and I'll write this whole thing up for you so you can, since I haven't talked about this one before. So this is Mr. Gill's #1 rule. You can abbreviate, like I'm typing it out because that's easier when I'm using the keyboard. You could use, if you know the symbol for number, you could use that little symbol that means number. You probably call it a hashtag, but it really stands for number. And then you could put the #1 instead of writing it out. So when you're taking notes, just remember, abbreviate stuff. Don't necessarily write exactly what I'm putting up. So Mr. Gill's #1 rule. There we go. I'm going to write for solving. It could be when solving. Is. We'll just do this. Whatever you do to one side, you do the exact same thing to the other side. Okay. So I'll leave that up unless you can copy that, and I'll explain what that means once you get it all. Oh, that's not what I wanted. There, that's, and we'll make that red so that it stands. All right, so there are 2 pieces you need for equations. You need to understand what they are, and then you need to make sure that you have this #1 rule ingrained. Like everything you do when solving equations needs to revolve around this definition, and I'm going to give you another definition in a second, and then that rule when you're solving.
Do we have to?
As long as you know how to solve, but if I'd write them down, because if everybody was fantastic at solving equations, again, it's fine to not be good at something. If everybody was fantastic at solving equations, you probably wouldn't be in this class. Yeah, in a minute. Let me get the next definition out. All right, so here's another definition. What is solving for a variable? Like, what is solving an equation mean? Solving for a variable. Anybody want a shot at that? Again, I'm doing things a little differently this year because we're changing our the way we grade, which means I can kind of just move forward with lessons a little more. But we are going to talk about this. So here's your last step. So again, this is a definition that I'm about to give you. So this is Mr. Gill's definition of solving. Solving an equation or solving for a variable. It just means get that variable along on one side. Now, again, use your own words. I'm typing this out in a lot of words. If you can shorten that up, shorten it up. So that is my definition of solving for a variable. Make sure you go back and watch this because this is kind of the heart of the first quarter right here, solving equations. And we'll still do some word problem stuff off and on. especially since some people are going to need to probably make up that. So you need to have those three things memorized, ingrained in your head, drilled in your head. Like that's what everything revolves around for the next at least 2 weeks when you go to solve. And if frankly, if you really do have those, you can't mess up. It might take you a little longer to get to a final answer because you might do the wrong thing during the process, but you'll never actually mess the equation up if you understand those three things, or even just memorize them. And we're going to come back and solve for now. I just wanted you to understand it's like a scale. If I put something on this side of a scale, it's out of balance. That side's going to go down, the other side's going to go up. That doesn't work. I can't just do something to one side of that scale. If I already have weights on it and it's anything on it, we'll do my best. So if you ever know what a weight is, they are little metal things that they actually used to use to weigh stuff. That's the way they used to do it. Each weight would have its own, each little weight would have its own weight, like 5 grams, 1 gram, half a gram, whatever. And they would stack them up. They'd put the item on one side. They would stack the weights up on the other side. And once it was even, they knew that's how much the item weighed. That's actually how they used to have to weigh stuff. There were no scales where you just step on it and it tells you your weight. So if I now add a weight on this side's going to go down. Well, I would have to add the same exact weight to the other side and get it back. That's the concept. What's a variable? You don't know these automatically, you better write them down every time we say them. Just an unknown number. So again, when you see a letter, you've got to think, okay, that's still a number. And there's math going on with that variable. I just don't know what the number is yet, so I can't actually get an answer. So if you see, let's go way down here, or not. Oh, what is that? God. What is that? It's getting worse and worse every. So, oh boy, it's gonna write way off. I guess I'll do my best. 3. I'll write really big. That might help. Oh, there. 3x is just a number. We don't know what that number is yet because we don't know what x is, the variable, but it means 3 times x. And once if I can figure out what x is, I would do the math and I would then have the final number. So you got to remember, anything with a variable, I don't care how complex it looks. You could have division and fractions and multiplication and subtraction and still just a number. That's all it is. We just don't know what the number is yet, like the variable. We don't know what the variable is yet to be able to do all the math we need to do to get the final number, the value. All right, so. Oh, okay, so these are 2 review things. How do you change? So if I give you this number, I give you 4. Best I can do is 4. If I say I want to make that into a fraction, how do I make a whole number or an integer into a fraction? It's done the same way every single time. Doesn't matter what number it is. You can actually even do it with a decimal or decimal. How do you make something into? You need to write this down if you don't know it. I give it to you. Anybody know it? How do you turn that 4 into that still equals to 4? Can't change the value of 4. Still got to be equal to 4, but you want it to look like a fraction. So a number over a number. How do you change it? Got a guess? What do you think? Not a variable. It's going to be an actual number, but yeah, you do just make it look like a fraction, but there is a specific number you have to choose. Are you answering, Amaya, or are you, what do you think, Jocelyn? What about one? Exactly right. Any number, I don't care what it is, any number. If you want to change it to a fraction, you do this. Ah, my board doesn't work. Oh, I don't know. Oh, here, let me do this. Let me guess where it goes. Here, it's really big, but that'll work. You take that number, you make it look like a fraction. So I put this line here, and then you put a 1 on the bottom. Any number. You need to write that until that is ingrained in your head and you can't possibly forget it. You write that down every single time that you put it over 1, because you're going to do that in all kind of lessons. When we get to graphing, you'll do it in graphing also, which is actually much later this year now that they changed the standard. So you take the number, change it to a fraction, which means you're putting it. And why does that work? Why is that? Why can I do that and still say that's still really just 4? On who? I'll call on Conan. Conan, why can I do this? How can I just change that to a fraction and say it's still 4? It's just division, right? All I'm saying is 4. We said this line means division. That's what a fraction is. I'm just saying 4 divided by 1. What's 4 divided by 1? Still 4. I didn't change the value of it. It's still 4. I made it look different, but it's still a fraction. I mean, it's still 4. 4 divided by 1 is still 4. Now, though, I have a fraction that I can use if I have other fractions in the problem, and I can now do the math that I need to do between the fractions. How do I multiply fractions? If I have that fraction there, how do I multiply? No division necessary. So how do I multiply? What do I do? 4 times 4, like you see the fraction I'm talking about, right? 3 over 7 times 4 over 5. What do I get to do the final answer there? It's actually the easiest thing you can do with fractions. It's easier than adding them, subtracting them, certainly easier than dividing them. What do I do? What would like looking at that, what would the easiest thing to do be?
3 times 4.
Yeah, just multiply straight across. So that, oh boy, I gotta fix it. So this is really 3 times 4 divided by 7 times, that's a multiplication symbol. It's supposed to be a 5. That's what it is. You just take I don't know how to do that. All of this stuff is key. If you don't know an answer, you better be writing down what I tell you every single time, because a lot of you are not. So the final answer there would be 12 over 35. Now, if you can simplify it, you do simplify it. I'm not going to get into that right now because that's not crucial for the lesson, but we'll do that during the lesson. Simplify would mean like 5/10 is the same thing as 1/2. Okay, simplifying in terms of that. 2/4 is also 1/2. Any questions on any of that before I move on? That's why we need to understand fractions and multiplying. You don't cross multiply if you're just multiplying. If we do a proportion, that's when you cross multiply. And that's why we're talking about fractions and how to change a number into a fraction. It's because we're going to be solving some problems like that. I've never taught it that way before. I'm going to try it this year and we'll see how it goes. All right, any questions on any of that? That stuff at the bottom was actually for a word problem that we didn't do. We'll probably do that word problem next class. Maybe. All right. Getting worse and worse every time I touch the board. So again, keep in mind as we're going through and solving these 3 things. So an equation just means the value of the left has to equal the value of the right. Because we have to say that the value of the left equals the value of the right, anytime we change one side, we have to do the exact same thing to the other side so that we keep it in balance. And then all solving really means is getting the variable all by itself on one side. So horrible. Let's see, and we're going to get to the book pages in a second. Not worry about that just yet. We already did what is a variable. That was my handy stuff. All right. I don't really want to start with that one. All right, tell you what, let's just go to the book pages and they start you with some pretty simple ones. So look at example 1 out of what you just tore out. And I don't have them torn out. Try, I think it's just an equation, right? So, oh boy, that's a pretty tough one to start out with. Scratch that. Oh man, we tore out the wrong. Son of a gun. All right, we'll tear the rest of the pages out next. I totally started you on the wrong page. I'm going to write this up. So just for today, copy this down. And I'm even going to start you even easier than what they're doing. God dang it. So this is going to be way off, but actually, I'm not going to start you off. Erica, I can't even deal with this. Oh, let me try again. So yeah, we're missing a chunk of pages, so I'll just, it's the more basic. Oh, actually here, I know what I'll do. I think I have enough of them for this class. Or maybe the next class, I'll just tear out. Let's do this. I already have some of them from other stuff that we were gonna use. Take one and pass it back. Hopefully I'll have enough, if not. This will get us started. Bring up the same thing what you did there. Take one. If you have an extra, just put it on an empty desk by you or something. You guys need to wake up. All right, so the first problem, it says negative. Oh, am I going to try to do this? Boy, I got to try to do it up here because I'm recording. Oh, all right, working a little better. I'll go back and fix that. Negative 5p plus 2 equals negative 43. All right, so there's your problem. We're going to solve for that variable p. I want to know what does that, and the reason I can solve, so if you don't remember this, write it down. If I have one variable, only one variable in an equation, so one equation, one variable, I can solve. I don't care how many times that variable shows up. I don't care if it's on both sides or just one side. I don't care what the numbers are. If I have one variable and one equation, I can solve for that variable. Guaranteed. If I have two variables in one equation, I can't. But one variable, one equation, I can solve. So I can find out what that p equals. Variable p, it's a number, and I'll take it one step further. The math going on is that negative 5, remember 5p means negative 5 times. So there's another one you got to remind yourself of. So that's the math going on. What was that? I'm just showing you that means multiplication. If you already know that, you don't need to rewrite it. If you didn't remember that, watch this. If you didn't remember, then yeah, I'd write that down. Every time I show you something you don't know, I'd write it down. Yeah, you can always get up to show me this. Unfortunately, there's not a great one on that side. That manual one doesn't work great, so there's one back in that corner by all the baskets. Yeah, again, all I do sometimes is explain something. If you already know it, you don't need to write it down. If you didn't know it, then you need to write it down. So we have now this equation. Again, I don't know what P is, but it's some number. And if I took that number and if I multiplied it by -5, and then if I added 2, this side would equal -43. So I just got to figure out, okay, what number would make that work? Anybody tell me what the number is? Sometimes you don't even have to go through all the steps of solving if you're good at what's called mental math. I can tell you what it is right now. It's not super hard. Especially if you're okay with your multiplication tables. Well, let's say it was 2. What would 2 times -5 be? What's 2 times 5?
Negative.
So -10. And then if I add +2 to -10, I get -8. Well, 8, because it's a positive and a negative, which we'll go over another time. So that's not right. It's not even close to -43, regardless of what it is, even if it was -12. So that can't be the right answer, because if it's the right answer, it'll make this side equal that side. And we'll get into that definition next class, what an answer is. So just guess. Take another guess. It wasn't 2. 2 didn't work. Or make people guess. No, guess that you were hit down. Just give me a number. 12. So we said, let's see. 12. I'll do the math for you for now. 12 times -5 is -60. -60 plus 2 is -58. Is that the right answer? Nope, didn't make the left side equal the right side. The answer will make the left side equal the right side. That's actually what the definition of an answer is. The number that makes the left side equal the right side. Come on, give me an answer. Give me a guess. Throw a number out. We did 2, we did 12. 2, okay, I'll give you a hint. 2 was too low. 12 was too high. So now give me a guess. Come on, girl, just say a number. All right, somebody said it for you. 9. So 9 times -5 is -45. -45 plus 2 is -43. That's the answer. The answer is just the number that if we plug it back in, we put it in for the variable, and we do all the math, it will make the left side equal the right side. And 9 did. 9 was the number. That's me. Was I holding somebody from the bathroom? All right, yes, but we are covering a lot today, so hurry back. I can't find the little card that I had for you either. I'll have to find it for you. Remind me before you leave. So really, now I still am going to want you to show your work for a little while, because that's the only way I truly know that you're getting it, is to see how you figured out that number. Even if you just plug it in and show me that the left side equals 43 or -43. Here are the steps. Now I'm going to teach the steps differently. I used to have a whole sheet that you go through these steps, you'll solve it out, but kids weren't using the sheet enough because you had to practice with it. And then it wasn't helping them any because they weren't willing to really practice with it. So I'm going to try to change it around. And we're going to just use those definitions and see if those 2 definitions and then the Mr. Gill's #1 rule will be enough for you to solve. I need to get, so what did I say solving means? What does solving for a variable really mean? You wrote it down a minute ago. What's it mean? Oh, I have to call on people today. Where'd I end up? Snow answered to my left. Keyshawn, you've been answering. We'll go with Dave. David. You go by Dave or David? Dave. Okay. David, what did I just say solving really means? Solving for a variable. Wrote it down. Should have written 3 things down, but that was one of them. get the variable alone, right? Is that what you had written down? You need to get the variable alone. Just think about it. When I just told you the answer, when I just solved out, we got into this. P equals 9. That's where we got to a second ago by just kind of plugging numbers in. Isn't the variable all by itself? Like there's nothing else on that side with that variable, right? That's all solving is. Get all the variables together, which is combining like terms, get them all on one side, and then get rid of all the numbers on that side so that you just have the variable. Now, in this case, we're already kind of close to that because we don't have any variables on the right. All we have is that number. We don't have variables in multiple places on the left, so we don't have to worry about trying to combine them. We just need to get rid of this -5 and that +2, or that +2. So here's the net, and again, this is different than I normally teach it, but we'll see how it goes. Not allowed to, come in.
Please.
Not allowed to. So,
Right.
I need to get rid of that 2 and that -5. Does anybody, I didn't do anything. Does anybody have any idea what I need to do first between the +2 and the -5? You got a 50-50 chance. It's either get rid of the 2 or get rid of the 5. What do you think?
What you do is put one to then,
All right, so that wasn't what I was thinking, but we will do that. I like that. So Ryzen just said this. Hopefully you've kind of seen this before. Oh. Sometimes I think I've got ghosts in my machine. So we separate the left and the right side, because remember, we got to keep the left and the right side even, which means whatever I do on one side, I got to do on the other. If you don't separate it, sometimes you are going to wind up breaking that rule. So separating it is always a good idea at the very first step. So now I want to get rid of that -5 and that +2. Where do I start, do you think? Which one?
switch the plus to the minus of the 2. Then
Why
one,
are we getting rid of the 2 instead of the 5?
so you can then later divide the 5 to the 4.
Why don't we just divide right now?
Because you
Sure, I can do anything I want to both. That's my number 1 rule. I can do anything I want to both sides, as long as I do it to both sides. Anybody can, and if you can't answer that,
but you're also trying to get
if you can't answer that, then you're getting it at a much higher level, but I don't expect really.
-40.
No, we would never do that. And I'll come back to that because I want to get this. I want to get this by itself.
So then-
I don't care what's going on over there. I wouldn't do +2 because again, I'm trying to get rid of the 2. So let's talk about that first. If I do +2, and I now mathematically, yeah, I can do that as long as I do it on both sides. I could say, boy, I was going to do this differently, but my board's not working great. I'm going to rewrite the whole thing. So I could say -5p. I'm not going to put the multiplication in for now. I could say +2, and I could say, well, I need to add 2 to both sides. I'll add 2 there. Whatever I do to one side, I got to do the other side. So -43 + 2. Did that get rid of the 2? Because I'm trying to get p all by itself, which means I need to get rid of that, and I need to get rid of that. Did it get rid of it? I mean, I guess it did get rid of the 2, but did it get rid of that number? What do I have on the left now? I still have the -5, but now what do I have? Well, no, what's 2 + 2? I didn't get rid of anything. If I'm trying to get the variable by itself, just adding the same number to that side. Now, it wouldn't keep me from getting the right answer eventually, because I could. If I then did the correct step, I'd still get the right answer because I added 2 to both sides, so it's still a balanced equation. But it's going to now take me one more step to solve it, assuming I start doing the right stuff. All right, so if we're trying to get rid of the 2. Now, so as far as division goes, I'm going to give you the short version because you got to get some practice time in. I could divide right now, but here's why you don't want to. If I divide right now, it would get rid of it. Like if I divided by -5, it would get rid of the -5. That would be gone. But the problem, and I would divide by -5 over there, which that'd be fine. Problem is, if I have two terms in the problem, I would actually also have to divide that by -5. And now I just changed a number into a fraction, and that's kind of messy, and I really don't want to deal with that. So dividing first is not your, again, this is not 100% of the time. I'm just going to tell you this as a general rule for now, and then down the road we may have to adjust it. You're never going to divide first. Like division is going to be the last thing you do most of the time. There's almost never a you might multiply first, possibly, but really, I don't even expect you to have to do that. I can go fast. So we always want to think about, especially if it's a more simple, this is called a two-step equation, you're typically going to be adding or subtracting first, or maybe multiplying first. But don't ever start with division for now. If that we get to some tougher problems, then we'll adjust that. But really, you're never going to start with division. So I'd write that down. For now, don't ever start with division when you're solving for the variable. So say, I think, Ryzen, you told me what to do then. What should I do first? Well, we don't switch, because again, you have to, what's my number one rule? I'm getting the variable by itself, but I want to do something to both sides. So I don't want you to think switch. I want you to think like cancel it out, like get rid of this. How do I get rid of 2? If you have 2 apples in your hand, how do I get rid of them? You take them away, right? I take them from you. I subtract them from you. So if I want to get rid of +2, I really want it to cancel out and go to 0 is what I'm really trying to do. I want there to be a 0 there. Well, the way I get rid of a +2 and get it to 0 is I subtract 2. 2 subtract 2 is 0. So you're really trying to get to 0 for that number. Because now if I get that to 0, well, what's -5p plus 0? Well, it's just -5p. So I got rid of the 2. Again, if you're not following that, if you do enough of these, you'll just get the process down. What's my number one rule, though? If I do this, I've got to immediately come, and I don't do anything different at all. I don't change the number. I don't change the math. I say subtract 2. Now, we'll work on math later. You're not going to have a calculator during this lesson because you don't get a calculator the first day of the EOC next year. So you got to know how to combine these, which we'll work on later. Today is more of a concept day, process day. -43 subtract 2 is -45. The quick version of that is if you're let's always think of money when you're dealing with integers, positive and negative integers. If I say you're in debt $43, like Nathan, you owe me $43, right? That would mean you're negative, right? Not only do you not only you're at 0, you're below 0 because you owe me money. If you get money, you got to just give it to me. So you're -43. If you then somehow borrow 2 more, so now you owe me 2 more, you are more negative. You're more in debt. So if you're already -43 and I take 2 more away from you, like you get a bill in the mail as well, you can later over that whole concept. You're now more negative. You're worse off than you were before. So you're -45. This cancels out. +2 subtract 2 is 0. So I'm going to write the whole thing out. So I'd have -5p plus 0 now. Well, like I said, -5 plus 0, I don't need the plus 0. So that's just -5p. What does the -5p mean again? What's that mean? -5 next to the p. What am I doing there? I'm going to go with my other Jocelyn. What does that mean, Jocelyn? -5 next to the p. What are we doing? Well, what are we doing? What does it mean the way it is? Don't worry about the next step yet. Well, you're right. What's that mean? What does -5 next to p mean? We said at the beginning of the problem. That means I'm multiplying. So here's the next concept you need to understand. Solving for a variable is like going back and doing all the opposite math. It's like we're kind of undoing everything that was done in the equation. That's why we subtracted 2, because what was going on was adding 2. So we did the opposite. If this is multiplication, we need to do the opposite to get rid of that -5. And don't forget the negative. You need to think the sign in front of a number. You need to write this down. The sign in front of a number, and by sign, I mean plus, minus, positive, negative. It is glued to that number. Wherever the number goes, that sign goes with it. So if that 5, if I'm going to divide by that 5, I've got to keep that negative with the 5 when I divide. That's one of the biggest mistakes that kids make. They'll just decide to divide by a positive 5. The sign in front of a number, so in this case, I've got a negative in front of that 5. That negative is glued to that 5. If I divide by 5, I got to divide by the negative also. And then that means over here, I do the exact same thing, number 1 rule, including the negative. Divide by 5 or -5. So now here's what happens technically. What is -5 divided by -5? Carson, what's -5 divided by -5? 0. Boy, I hate it when people say 0. I don't know why everybody chooses 0 on that one. Not 10. What's 3 divided by 3? What's 3 divided by 3? Anybody? Nope. Nope. 3 divided by 3. Amaya. 1. What's 5 divided by 5? Just 5, regular 5. What's 10 divided by 10? What's a million divided by a million? What is -1 million divided by -1 million? 1. Any number divided by itself. If you're taking the number and dividing it by itself, it's 1. Any number. 0.0389 divided by 0.0389 is 1. If you divide a number by itself, it's 1. So if I'm taking -5 and dividing it by itself, 1. So that's 1p equals negative divided by a negative is positive. What is 1 times p? What is any number times 1? Any number times 1 is what? Not 1. Any number times 1 is
0.
Not 0. Somebody just said it. It's the same number. If you multiply anything times 1, it's the same number. So 1 times p is really just p. I don't need the 1 is what I'm saying. That's why you never see a 1 in front of a variable, even though technically it's there. Technically, that is 1p. I don't need to show the 1 though, because they're the same thing. 1 times p is just p. So that now we have gotten the variable alone all by itself. We got it. Normally, when you do that, if there's only one variable in the equation, you should just have a number on the other side, one number. By the time this is all alone, there should be a number. Now it might be a fraction or a decimal, but it should just be one number on the other side. And that is the answer. Because if we plug it back in, we know it works. That's how it works. So I want you to start working on. Actually, I'll give you a couple to work on that are pretty similar. Now, let me just make sure you understand. We are not always going to subtract first. We subtracted because this was addition. We wanted to get it to 0. Plus 2, subtract 2 is 0. If that would have been subtract 2 here, I would have said plus 2 there. So you have to do the opposite thing. So for example, look at number 3. It says plus 5. Well, actually it's the same thing. So that's the same thing. Sorry. Where's one? Do they have some subtraction? Number 16. Oh, it doesn't matter, by the way, which side things are on. This equation here, it could have been written like this, because remember, the left side's equal to the right side. I don't care which side they're on, they're still equal. So that's the same equation. I can always change the sides. You can't change the order of things. Like I couldn't have made this 5p subtract 2. I can't change that. But I can always take what's on the left and put it on the right, and take what's on the right and put it on the left. I think somebody's out. So, is it? Oh, okay. I thought there was somebody out over there, but I guess that's an empty desk. I go quickly because I want to make sure you practice this a little bit. So trade your phone out for the green pass. We have a new pass now. I don't know. Hopefully Keyshawn has done that. You can just put the phone up there. So remember, do the opposite math. That's why we divide at the end, because normally multiplication is going to be what's in the problem. So that means at the end we divide. We do the opposite. Don't worry about the ones that have fractions in them for right now. We're going to do those probably next class. That's why we learned the bell work and the multiplying fractions and that stuff. Well, sort of. I'm going to tell you to do one. Well, we already did one. Do number 3. Do number 6. Do number 7. 7's a little tricky. 9 is a little tricky. 10, 14, 16, and 17 for today. So those are the ones you do. Somebody read them out again. Somebody home. 8, 6, 7. Get it? Whichever one you missed. Actually, just here, read them out and I'll write them. What were they again? There. The ones in blue. I don't probably can't erase the red without erasing some of the blue, so just the ones in blue. I'll walk around and help. I don't care if you work together. I encourage you actually to work together. If you normally 2 people together can figure out a lot more than 1 person alone. So check your answers, work together on the steps. They're all 2-step equations though. You're either going to be adding or subtracting the number first to get it to 0. Remember, whatever you do on one side, you then have to do the same thing to the other side. And then your last step on all of those is going to be division. I gave you problems that were just like the example we did. We'll get into some different ones next class. Did I do attendance? Remember. And these are called 2-step equations. Find the attendance, and I'll start walking around. Do with those down first. Yes, I can probably stop the recording. If I do anything that's important, I'll just repeat it next class. I don't know. Oh. Oh no, boy, I should take that away from you right now. I can't believe this. It's not phone time, especially not playing pool on your phone time. What do we say you start with? What's first step on all of these? Which term do you start with? There's one term that has a variable in it, one term that doesn't. Which one do you start with? The one with the